We're going to go through the odd numbered review problems. There will be another video in which we go through the even number review problems. So let's start with writing in algebraic expressions to represent verbal expressions. Now remember, verbal expressions, okay, is what's written here in numbers 1 through 8. Okay? An algebraic expression is going to contain a variable. So when it says the difference of a number and 11, well, that difference tells us we're going to use subtraction. Okay? And remember, anytime you see the word a number written, you can automatically replace that with a variable. So in this case, we'll call it x. So really, this reads the difference of x and 11. Well, remember, difference is subtraction. So if I'm taking the difference of x and 11, it's going to be x minus 11. A number to the fourth power times 5. One of the things I always tell my classes is anytime you see a number, just cross it off and write x. So really what this stands for is x to the fourth power times 5. Well, how would I write x to the fourth power? Well, that would be x to the fourth. Times means multiplication, so times 5. So I can put the 5 in front. 5x to the fourth. 5 times x to the fourth power. Number 5 says the product of 4 and the sum of 10 and x. That's kind of a tricky one, so let's walk through this. When it says the sum of 10 and x, well, we know the sum of 10 and x means 10 plus x. So what does it mean when it says the product of 4 and the sum of 10 and x? Well, let's read it now that we've written out 10 plus x. Now it reads the product of 4 and 10 plus x. Well, if I want to multiply 4 times 10 plus x, I need to make sure that I put 10 plus x in parentheses, because I'm multiplying 4 by the quantity 10 plus x. So the answer to this one would be 4 times 10 plus x. Number 7 says twice the sum of x and y. Well, again, let's take this one step at a time. When it says the sum of x and y, it's x plus y. So twice the sum of x and y. Now, don't get confused on where we put the 2. I'm not just going to put the 2 in front of the x or in front of the y or after the y. It says twice the sum of x and y. So I need to multiply the entire sum by 2, and that's why we put the parentheses around it, because it's twice the sum of x and y. Alright, now we're writing verbal expressions here, and there's lots of different ways we could write verbal expressions. So the answer that I write might not always be the correct one. There could be other ones. So when it says 2x to the fourth power, okay, well, one verbal expression that I could write would be x to the fourth power, x to the fourth power times 2. You could have also written the product of 2 and x to the fourth power. That would have worked as well. When it says 3x minus 10, remember the subtraction ones get a little confusing, but one way you could write this would be 10 less than 3 times a number. 10 less than 3 times a number. Remember, anytime you see x, that always means a number. So 3 times a number, that's what gives me the 3x, and it's 10 less than that. You could have also said 3 times a number decreased by 10. Okay, there's lots of different answers for these. Alright, let's go to some order of operations problems now. I have 12 plus 6 divided by 2 minus 5. Okay, well, again, let's write please excuse my dear Aunt Sally. So we can refer to that. Just remember, multiplication and division go hand in hand. Multiplication's not necessarily first. Same thing with addition and subtraction. Addition's not necessarily first. We always go left to right. Well, here we don't have any parentheses or exponents. So let's go to multiplication. Don't have any of that either. I do have division though. 6 divided by 2 is going to give me 3. So I have 12 plus 3 minus 5. And now I work left to right. So 12 plus 3 is 15. 15 minus 5 is 10. Alright, number 15. I do have some parentheses here, so let's work with that first, okay? 4 times 3 gives me 12. So here I have 2 times 12 minus 3, and then 9 divided by 3 in parentheses is going to give me 3. So I have 2 times 12 minus 3 times 3. So I've done my parentheses. I don't have any exponents. I do have multiplication left to do now. So 2 times 12 would give me 24. And 3 times 3 is going to give me 9. So it's going to be 24 minus 9. And that's going to give me an answer of 15. Alright, let's go on to number 17 here. I have 3 squared plus 12 divided by 4 times 8 minus 12. Okay? Well, again, don't have any parentheses, so let's not worry about that. I do have exponents, though. So 3 squared is going to give me 9. So I have 9 plus 12 divided by 4 times 8 minus 12. Okay? So now let's keep going. So multiplication. I do have multiplication and division, but remember, now this is important. We work left to right, okay? Because the division actually comes first here. So really I have to do 12 divided by 4 first. So I'm going to have 9 plus 12 divided by 4 is 3. This comes first. 12 divided by 4 is 3 times 8 minus 12. And now I can do my multiplication. So now I do 9. 3 times 8 is 24, plus 24 minus 12. And now I work left to right with addition and subtraction. So 9 plus 24 would give me 33. And 33 minus 12 would give me an answer of 21. Alright. Number 19. Let's do our parentheses first. I have that 4 minus 2 in parentheses, so I have to deal with that. So I'm going to have 23 plus 6 squared is going to give me 36. Okay, actually let's hold off on doing that because I want to just do our parentheses first. Minus 4 times 2 cubed. Now we can do our exponents. So 6 squared is 36, so I have 23 plus 36. 2 cubed is going to give me 8. So minus 4 times 8. Okay, now we deal with our multiplication, so that's going to give me 32. So I have 23 plus 36. 4 times 8 is 32, minus 32. And now we can work left to right. So 23 plus 36 is going to give me 59. And 59 minus 32 gives me an answer of 27. Okay. Alright. Let's go on to the next page. Alright, now we're evaluating expressions. So these are still order of operations problems, but we're going to be plugging values in. It says evaluate each expression if a equals 2, b equals 1, c equals 1/2, d equals 3. So if I have 2 times a plus b, I'm going to plug in 2 for a and 1 for b. So I'm going to have 2 times 2 plus 1. So 2 times 2 would give me 4. And then 4 plus 1 would give me an answer of 5. Alright, 23. Okay, I got d. So d is 3, so I'm going to have 3 squared plus 2 times 2 to the third. So I have 3 squared plus 2 times 2 to the third. Okay. So let's see what we got. Let's do our exponents first. So 3 squared is going to give me 9. plus 2 times 2 to the third, because that's right, I plugged in that 2 for a. So 2 to the third is going to give me 8. That's, remember, 2 to the third is 2 times 2 times 2, so that's going to give me 8. So I have 9 plus 2 times 8, and now I go order of operations. Oh, let's write that. Let's write the order of operations over here, just so we can always refer to it. So I have multiplication, so I have 9 plus 16, because 2 times 8 is 16, and that's going to give me a final answer of 27. Well, not 27, sorry. Mental math error. 25. Alright, so now again, let's plug in, let's show our substitution step. So I'm going to plug in 2 for a. Oh, wait, are we doing 20? No, we're not doing 24. That'll be on the next video. Let's go to 25. I have 2 plus a plus d to the third, so that's going to be 2 plus 3 to the third power. Okay, so 2 plus 3, we do what's in parentheses first. That's going to be 5 to the third, which, remember, 5 to the third is just 5 times 5 times 5. So that's going to give me 125. Alright. Alright, so now it says simplify each expression. All work must be shown for credit. So make sure on the test on Friday you show your work. These are going to be problems we're going to distribute, and if needed, we're going to combine like terms. So I have my 7 here. Let's distribute the 7. Okay, so 7 times x gives me 7x, and 7 times 3 gives me 21. Now always remember, it's really 7 times negative 3, because I got that negative sign in front of the 3. So I have 7x minus 21. Now remember, I can't combine these, so this does not equal negative 14x. Do not do that. Okay? Remember, when we combine like terms, they have to have two things in common, right? Like terms have the same variable, okay? And those variables have to have the same exponents. If a term does not have the same variable and same exponents, you cannot combine them. Alright, so let's go to this next one. 3x squared y plus 12x squared y. Well, is 12x squared y and 3x squared y, are those considered like terms? Yes, they are, because there's the same variables, x and y, and those variables, meaning the x, has the same exponents. So this would be 15x squared y. Now remember, when you combine your like terms, when you combine 3x squared y and 12x squared y, you do not add the exponents. The exponents stay the same. Well, it looks like I just did an even. Didn't mean to do that. Well, the extra bonus problem for you guys. Alright, number 29. 1/2 times 4x minus 8. Let's distribute the 1/2. So 1/2 times 4x is going to give me 2x. And 1/2 times negative 8 is going to give me negative 4. So I have 2x minus 4. Okay, so remember, when you distribute fractions, you're going to multiply the fraction, the numerator of the fraction, by the number you're multiplying it by. So when I do 1/2 times 4x over 2, that's really 4x over 2 minus, remember, always look out for that term, minus 8 over 2. And when I simplify that, that's how I get 2x minus 4. Alright, a double distribute problem. Let's distribute this 3 and then distribute the 6 and combine our like terms. So 3 times 5x is 15x. 3 times 2y is 6y. 6 times 5x is 30x. And 6 times negative y is negative 6y. So this should be 30x minus 6y. Now we combine our like terms. So if I combine my x's, 15x and 30x is 45x. And 6y and negative 6y is going, those are going to cancel out, right? 6y plus negative 6y, those are going to actually cancel out. So all I'm left with is, all I'm left with is 45x. Alright, let's go down to number 33. Distribute that 2. multiply the 2 by everything in the parentheses, so that's going to give me 2 times 3a is 6a. 2 times 2b is 4b, and 2 times 8 is 16. So I have 6a plus 4b plus 16. Are any of these like terms? Nope, different variables, and here no variable. So that means I don't combine them, and that's my answer. Alright, let's distribute this fraction now. When I distribute 1/4 to 12b, remember 1 times 12b is just 12b over 4. 1/4 times a negative 16 is minus 16 over 4. And now don't forget to distribute the negative. Okay, distribute that negative. So if I distribute the negative 1 times 3b, that's minus 3b. And negative 1 times 8 is negative 8. So remember, that's 3b, not 36. So when I simplify 12b over 4, I get 3b minus 16 over 4 is 4 minus 3b minus 8. Alright, I'm not done. I gotta combine my like terms. 3b and negative 3b. What's 3b plus negative 3b? Well, those are going to cancel out. So that's going to be 0. And then negative 4 and negative 8, when I combine those, I'm going to get negative 12. Always take the sign in front of the number. So your answer to 35 would be negative 12. Alright, let's go on to 37. I have 0.3 squared. Okay, so remember our rule. If I'm squaring a decimal, 0.3 squared, I'm going to move the decimal over to give myself a problem that I like. So now this is going to turn into 3 squared. And 3 squared is 9. Okay, but now we move the decimal over whatever our exponent is. Okay, so I have 9. So I'm going to move it back 2 spaces, 1, 2. So my answer is going to be 0.09. So you always move the decimal back without however many places your exponent is, or whatever number your exponent says. Alright, let's do number 39. We have 5 over 9 minus 3 over 8. So our goal here is, remember, if there's ever an addition or subtraction sign here, you cannot cross reduce. So you cannot change this 3 to a 1 and that 9 to a 3. You can't simplify that. That's only with multiplication. With addition and subtraction, we really need to remember that we are going to get a common denominator. Okay, so what's a common denominator of 9 and 8? Well, if nothing comes to mind, okay, remember we write 9 here and 8 here and we start counting. So with 9, that's going to give me 9, 18, 27, 36, 45, 54, 63, and 72. With 8, again, start counting. It's going to be 8, 16, 24, 32, 40, 48, 56, 64, and 72. So notice that the lowest number that the multiples have in common is actually 72. Okay, there's nothing else, there's no other numbers that they have in common. So I'm going to have to go down into our space over here because I'm running out of room. Our common denominator is going to be 72. So how do I get from 9 to 72? I got to multiply it by 8. That means I have to multiply the 5 by 8 as well. So that's going to be 40 over 72 minus, how do I get from 8 to 72? Multiply it by 9. So that means I have to multiply this 3 by 9 as well to get 27. So I have 40 over 72 minus 27 over 72. And remember, when I subtract these fractions, the 72 stays the same. Don't make this 0. Don't do 72 minus 72 equals 0. Okay? You leave the denominator the same. So now I do 40 minus 27 gives me 13. So my answer is going to be 13 over 72. And remember, this goes to this problem up here. Alright. let's go on to number 41. I have 2 over 9 minus 2 over 3. Okay, so again, I need a common denominator. Now what's nice about this one is 3 is a multiple of 9. So that means that 9 can be my common denominator, and I don't have to change the 9 at all. So I'm going to have 2 over 9 minus something over 9. Now how do I get from 3 to 9? Well, I have to multiply it by 3. So that means I got to multiply the 2 by 3 as well. So that's going to give me 6. So I have 2 ninths minus 6 ninths, which gives me an answer of negative 4 over 9. Alright, the last odd number on this page, we have negative 6 minus a negative, negative 10 minus a negative 6. So remember, minus a negative, okay? Minus a negative, I can switch that to plus plus. Anytime you have two negatives right next to each other, you can make those pluses. So that means I have negative 10 plus 6, okay? So remember, there's a couple ways you could do this. I could do negative 6 plus, or negative 10 plus 6. I could think about it in terms of a number line, where if I'm at negative 10 and I'm getting bigger, my answer is going to be negative 4. Okay, that's one way you could think about it. Or, what's our trick? If I have two numbers and their signs are different, I subtract them. So 10 minus 6 is going to give me 4. And I keep the sign of the bigger number. Well, what's bigger, 10 or 6? 10's bigger. So I'm going to keep the sign of 10, which is negative. So my answer, either way, is negative 4. Alright, let's go to our last page now. We have negative 9 plus 17. So again, you could think of it in terms of a number line, where you're at negative 9 and you're increasing by 17, so you're going to get an answer of 8, positive 8. Or, let's do our trick. The signs are different. This is a negative. The sign on the 9 is negative. The sign on the 17 is positive. So if the signs are different, I subtract them. 17 minus 9 is 8. And I keep the sign of the bigger number. Oh, what's bigger, 17 or 9? 17. So I'm going to keep that as a positive 8. So either way, whatever way works best for you, number line or trick. Alright, now let's add or subtract or add decimals. We have negative 8.5 plus 3.6. Okay? Well, I'm going to do the trick with decimals, because decimals for me are a little bit harder to visualize on a number line. So if I have negative 8.5 plus 3.6, since my signs are different, I'm going to subtract them. 8.5 minus 3.6. Okay, so remember, 5 minus 6, you can't do it. So you cross off the 8, make that a 7, make that a 15. 15 minus 6 is 9, and 7 minus 3 is 4. Keep the decimal where it's at. So I have 4.9, and I keep the sign of the bigger number. So I subtract, what's bigger, 3.6 or 8.5? Well, 8.5 is bigger, so my final answer is going to be negative 4.9. Alright, number 49, negative square root of 16 over 49. So remember our trick here. I keep the negative sign, but I can split up the square root. So it's root 16 over root 49. Okay, so the square root of 16 is 4. And the square root of 49 is 7. So I have negative 7 over 4 is my final answer. Or I'm sorry, negative 4 over 7. Alright, now we have plus or minus the square root of 1.21. Okay, remember, whenever we take the square root of a decimal, we want to turn this into a problem that we know. So plus or minus the square root of 1.21, I couldn't even do that in my head. So what we need to do is move our decimal out. So we're going to have the square root of 121, and we have to remember our rule with square roots. Our rule is twice out equals once in. Okay, so twice out equals once in. So the square root of 121 is going to give me 11. Okay, but I move the decimal out twice, but with square roots, for every 2 times I move it out, I only move it in 1 time. So that goes against our usual rule. So now the decimal is going to go back in. So my answer is 1.1. Alright, multiplying negative 5 times 9. Okay, well remember, if I have one negative and one positive, like I do here, negative and a positive, my answer is going to be a negative. So negative 5 times 9 is negative 45. Number 55, negative 63 divided by 7. Same thing with division. If I have a negative divided by a positive, or if I only have one negative, okay, then my answer is negative. So negative 63 divided by 7 is going to give me negative 9. Alright, let's go to number 57. Negative 7/12 times negative 8 over 9. Now remember, when you're multiplying fractions like this, okay, when you're multiplying fractions, you can cross-reduce. So can I simplify negative 7/12? No. Can I simplify negative 8/9? No. But I can look to simplify across. 8 and 12, well, that can reduce, since both are divisible by 4, that can reduce to 2 and 3. So really I have negative 7 over 3 times 2 over 9. And with fractions you can multiply straight across. So that's going to give me negative 14. Don't forget to multiply across. Negative 14 divided by 27. Remember, whenever you're doing multiplication, okay, whenever you're doing multiplication, you don't need to get a common denominator. When you're multiplying fractions, you just need to multiply across after you reduce, okay? Alright, number 59, the square root of 144. That means what times what gives me 144? Well, I know 10 times 10 gives me 100, so it's got to be bigger than 10. Alright, what's 11 times 11? That's 121. So lastly, let's try 12 times 12. If I do that, I should get 144. So that tells me that the square root of 144 is going to be 12. Now, be very careful, because there's something else we got to add to this. It's not just 12. Is there any other number that if you multiply it by itself, you get 144? Because 12 times 12 gives me 144, but so does negative 12 times negative 12. Because remember, a negative times a negative gives me a positive. So negative 12 times negative 12 would give me 144 as well. So we have to add the plus or minus 12 to that answer. Alright, let's go to 61 here. We have 1 4/5 divided by 2 1/2. So here's the trick here. Anytime you see a mixed fraction like this, automatically convert it to an improper fraction. So remember our little trick for that. If I want to convert 1 4/5 to an improper fraction, I do 1 times 5 is 5, and I add that to 4, and I get 9/5. Okay, so I have 9/5 divided by 2 times 2 is 4, plus 1 is 5, over 5/2. So I have 9/5 divided by 5/2. Now remember, here's the big part of this problem. Anytime you're dividing by a fraction, that gets really messy. So instead, we can multiply by the reciprocal. So I'm going to turn this into 9/5. Your first fraction will stay the same, times, now we flip this fraction, times 2/5. So I have 9/5 times 2/5, and now I look to see if I can reduce anywhere. Well, it doesn't look like I can, so let's multiply across. 9 times 2 is 18, and 5 times 5 is 25. So our answer is 18 over 25. Alright, last one on the odds video. I have 2 3/8 divided by 2. What I like to do is I'm going to make this 2 over 1. Because I want two fractions here. That'll help me visualize it better. So if I have 2 3/8 divided by 2 over 1, again, kind of like we do with 61, let's convert this to an improper fraction. So remember, first thing we do is we do 2 times 8, it's 16. 16 plus 3 is 19. And then this denominator stays the same. So I have 19 over 8 divided by 2 over 1. Well, remember, dividing by a fraction is the same, like we did over here, as multiplying by the reciprocal. So the 19 over 8 is going to stay the same. But now we're going to divide by, not 2 over 1, but we're going to flip it. So now, if we're not going to divide by anything, I'm sorry, we're going to do 19 over 8. We're going to multiply by the reciprocal. So 19 over 8 times 1 over 2, because I'm flipping this last fraction right here. Now I can see, is there anywhere I can reduce? Can I reduce 19 over 8? No. Can I reduce 1 over 2? No. What about cross? Can I reduce 1 and 8? Nope. 19 and 2? Nope. So now we just multiply across. 19 times 1 is 19, and 8 times 2 is 16. So I have 19 over 16. Okay. Alright, looks like we do have one more page here, so let's go down to our last page. We have one more problem. We're going to do number 65. Okay? Now, these are tables, so let's look for patterns here. Here it says the table shows the number of miles that Kate runs on a weekly basis while training for a race. How many total miles will she have run after 15 weeks? So after 1 week she runs 40 miles, 2 weeks she runs 80 miles, 3 weeks she runs 120 miles. So she's clearly, every week she's increasing by 40 miles. Okay? So every week she runs 40 miles. Okay? Whenever you're figuring out these pattern problems, always try to see how much, what is the unit. So here, if she trains for, every week she trains, she runs 40 miles. Okay, so each week is she runs 40 miles. So let's see if we notice any patterns. So we already picked up on the fact that every week increases her total miles by 40. So how many total miles will she have run after 15 weeks? Well, you could keep going down, and here 4 weeks, add 40 to this and make that 160. 5 weeks, add 40, 200, and so on and so forth. Add 40 every time, all the way down until you get to 15. You could do that. That's a little time consuming though, so let's see if there's a different way we could do this. Notice here that after 3 weeks of training, she runs 120 miles. So basically, every 3 weeks, okay, every 3 weeks, equals 120 miles. So, if she trains for 15 weeks, doesn't that mean she trains for 5 3-week segments? So if I want to find out how many miles she runs after 15 weeks, I could take 120 miles and multiply it by 15. Or you could say, so let's actually go ahead and figure this out first. So I'm going to do 15 times 0, or 5 times 0 is 0, 5 times 2 is 10, right, the 0 carry the 1, 5 times 1 is 5, add my 0, 1 times 0, 0, 1 times 2, 2, and 1 times 1 is 1. So after 15 weeks, she would have run 1,700, if I add these two together, 1,700 miles. Okay? Now, that's how some people look at it. Another way you could look at it is you could say, alright, each week she runs 40 miles. So if she runs for 15 weeks, okay, she might have to do 15 times 40. Okay? So for 15 weeks, she runs 40 miles. And let's see what we get here. 0 times 5 is 0. 0 times 1, 0. Add a 0 down here. 4 times 5 is 20. Write the 0, carry the 2. 4 times 1 is 4, plus 2 is 6. So wait a minute. How come if I do it this way I get 600 miles, but when I did it the other way, I got 1,700? Okay? That's because this way is incorrect. Okay? I can't take 120 and multiply it by 15. Instead, I have to take 100, if I wanted to do it that way, every 3 weeks she runs 120 miles, I would have to multiply 120 by not 15, but I would have to multiply 120 by 5, because there's 5 3-week segments. 5 3-week segments would give you 15. So, don't do the problem this way. Either do it one of two ways. Think about it as if she runs 40 miles a week, then 40 times 15 would give you how many miles she runs in 15 weeks. Or if she runs 120 miles every 3 weeks, then we have 5 3-week segments, so we can multiply 120 times 5, and that would give us our answer. 5 times 0 is 0, 5 times 2 is 10, and 5 times, carry the 1, and 5 times 1 is 5, plus 1 is 6. So your answer should be 600 miles, not 1,700 miles. Okay. Alright, now, another way you could have thought about this problem is writing it as an equation. Okay? And that's kind of what we just did, but let's actually write our equation out. You could treat the amount of training weeks as x and the amount of miles run as y, and you could have wrote the equation y equals 40x. Because every mile that she runs, if I multiply that by 40, I'd get the total number of miles. So that's what we did here, is we said if I want to figure out how many total miles she'll run in 15 weeks, I'm going to take 15 and I'm going to plug it in for x. And if I do 40 times 15, I get 600. So whatever way works best for you. This was the odd problems of the review. There will be another video for the even problems, so stay tuned for that and refer to this as needed.